All right. So drinks are on Daniel. I'm going to talk to you about GraphQL, AWS AppSync, and AWS Serverless, and I'm going to try and stay out of the projector, but that's going to be hard for me. I know there were a couple folks who were at the talk last week, so I'm going to try not to repeat too much of the same material. We're going to work at this from a different direction, but we'll also do a GraphQL introduction, so you guys can jump in and share your experience with GraphQL as well. That might be valuable for the group. But let's get started. So I'm Peter. I've been doing software for quite a long time. I've worn a lot of different hats. But I recently decided to refocus around full stack app development. And one of the reasons for that is I'm really excited about Backend as a service or serverless architectures. I think they have potential to solve some of the challenges we face in software application development. So in particular, I find one of the things that software companies miss the mark on is they're too focused on their big releases, their 1.0s, their 2.0s. I'm much more interested in focusing on 0.1, 1.1. I want to get software into the hands of users that they're interacting with so that I can start a dialogue with them, gather feedback, and work towards the right 1.0, the right 2.0 product. So I think Backend as a service or serverless architectures lend a lot in that regards. I also like to say I'm the furthest thing from precious about code. I'm happy to leverage the services provided by others, the libraries provided by others. If someone else has written code that I can take advantage of, I'm happy to do that, as long as it's the right service or library. And part of the reason for that is that humans tend to be the most expensive part of software development. So to the extent that I can cut that some of that cost out of the development process, I can make the economics work better in developing applications. Now, at scale, things change a little bit, but the first thing I hear from any big company is they want to act more like a startup. So this technology also has some promise in that area as well. So I just said backend as a service and serverless and kind of use them interchangeably. Probably we all have our own definitions or at least thoughts in our heads as to what they mean. I actually don't love the term serverless because I think it was co-opted by AWS Lambda. I think that's the first thing anyone thinks of when they hear the term serverless. I'm actually, when I say serverless, I'm actually thinking about how can I architect an application without deploying any servers, without writing any code that has to be deployed to servers. And specifically, I want to subscribe to services to put together my back end. And there's lots of cloud providers providing these types of services, right? Authentication, databases, file storage, hosting, functions, APIs, and that's what we'll get into tonight with AWS AppSync. So I'm going to say serverless for the rest of the presentation because backend as a service is too many syllables, but I do prefer that term, if we're being honest. Okay, so Daniel suggested that the group may not have that much familiarity with GraphQL, so we thought maybe it was worth going through a bit of a GraphQL primer or a little bit of an introduction. Anyone here familiar with GraphQL? I know probably the folks who go to the GraphQL meetup know it. So I'm not going to spend a ton of time here, but for those who aren't familiar, hopefully this will kind of catch you up very quickly. So the GraphQL folks define GraphQL as a query language for your API. I don't know that I love that definition, but it's okay. GraphQL as a technology originated in Facebook, and they published it as an open source specification fairly recently. I think if you're new to GraphQL, probably the easiest way to think about it is as a competitor to REST. I think people might argue that that's not the right definition of it, but it's a reasonable way for someone who's getting into GraphQL to think about it. There are ways that actually GraphQL can also complement REST, and we'll probably touch on that a little bit as well. Okay, so GraphQL is kind of taking the application development world by storm, and these are some of the reasons why. In GraphQL, you ask the API for what you want, and that's what you get, and only that. You also have the ability with GraphQL to get many resources in a single request. Discoverability or documentation is built into a GraphQL API, and we can work around some of the versioning challenges you have in REST with GraphQL. And like REST, it's just the API. So GraphQL is not opinionated about how you actually build your backend. So you can use it in a serverless environment. You don't have to. If you were building servers, it would be just as applicable. So we're going to get into these things in more detail and what I mean when I say these. This is the credibility slide. So these are folks who are heavy adopters of GraphQL. Probably the local ones are of most interest. So TELUS is doing a lot and actually is fairly active in the GraphQL meetup here in Toronto. Shopify has a public GraphQL API published. GitHub, the latest version of their API is all GraphQL. They're no longer using REST. Intuit has a major investment. Airbnb has made a major investment. New York Times is a frequent writer of articles around GraphQL. So it's become a really pervasive technology in app development. Okay, so probably most folks here are familiar with REST. So let's kind of compare and contrast. So one of the better descriptions I heard of GraphQL when I first started to get into it is that it attempts to take the good parts of REST and then improve on the some of the challenges with REST. So the stuff they have in common, the good stuff, they both use HTTP or HTTPS, right? So straightforward protocol, we all know. They both work with JSON. In fact, GraphQL only works with JSON, so you don't have an XML option with GraphQL. Both REST and GraphQL are just the API, again, unopinionated about what's in front of and what's behind the API. And both have a really good set of community tooling. It's kind of amazing. As young as GraphQL is, there's tons of community activity, and there's some really great tools built around GraphQL already, some really great client-side stuff, and some great libraries to help you build GraphQL servers as well. So where is GraphQL trying to improve on REST? That's what's on the right here, and we're going to get into these through example. But what GraphQL attempts to solve are the overfetching and underfetching problems of REST. And we'll look at what I mean when I say that. Reducing the need for versioning, and then also solving the documentation challenge of REST. So this might get tricky, but I'm going to attempt to show some of this by example. I'm just trying to. Yeah, give me back to. There you go. Okay, perfect. Okay, so I'm going to use everybody's favorite topic. I'm going to use Star Wars. So for those who aren't aware, there is a free, quote-unquote, Star Wars API available on the web. And someone has also wrapped the same Star Wars REST API in GraphQL, so you can compare and contrast. So I'm going to take a really couple of contrived scenarios to kind of illustrate what GraphQL is trying to do to improve on REST. So I want to get a list of all the names of all the primary characters from Star Wars movies. So my REST resource is at a URI or an endpoint called people. And I just got a response. So this is I actually got a paginated list back here. So I have Luke, I have C-3PO, I have Darth Vader, so we all recognize them. But all I wanted was the name. And then I got all this other stuff with REST. And by the way, this is a really good REST API, and it's good because included in the API are things you can do with these resources. So I immediately know where to go and find out about Luke's homeworld. I know where to go and find information about the films that Luke was part of. That actually makes this a really good REST API. But all of this additional data that they're giving me that I don't need, we describe as the overfetching problem. So even though all I wanted was name, I have to deal with all this extra information. So I want to show you what this same thing would look like in GraphQL. So this is, anyone who knows GraphQL is familiar to this interface. So this is GraphQL. We pronounce that graphical. So it's a graphical-like interface. All GraphQL APIs come with an interface like this, or at least can. So I'm going to write a query. It's going to be tricky with one hand. Okay, so I want to get all of the people. I'll get a count, and I'll get the people themselves. And I said all I want are name, so I'll get just the name. I'm going to execute that query. So there's the same thing executed from GraphQL. I have the same 87 results, but I have just the first name. So if you actually compare the size, so this is about, I think this is about 5,000 characters, so there's about 5K of data here. You may have noticed over here, this page I think is about 7,000 characters, 7,500 characters, but this is actually a paginated list. I only have 10 of the names on this list, so I actually have to make 9 requests to get the same data that I just got in the one query in GraphQL. So 7 times 9, so you're about, I don't know, 60, 65K of data versus 5K. So 10x more data. This is the overfetching problem that GraphQL is trying to solve. So let's talk about the other side of it, the underfetching problem. And some of that's exposed here, but let's use a different example to illustrate this. So I want to get the name of all the films that Luke is part of. So I would first query for Luke. This seems redundant because we have them on screen, but I'll do it just to do it. And then I can go hit the films endpoint, and I can look at, so he's got 1, 2, 3, 4, 5 films here. I can go grab the films that he's part of. So you see the overfetching problem is once again in effect here. All I wanted was this title, and I'm getting all this additional information. If I wanted to do this same thing in GraphQL, I'm just going to add the ID so I can grab it. Oh God, what's the shortcut on Mac? Command-C? Thank you. All right, so I think there's a person interface I can leverage here. I can apply an ID filter. And then I'll get, let's get the name. And I know if we actually look through what's available on this API, there's something called the film connection that I can leverage. And I'll get a count of the films, then I'll get the films themselves, and I'll go get the title of the film. So let's run this query. So there's the result. There's Luke, his 5 films, and the title of the films. So in one request, I got Luke and all the films he was part of. In REST API world, I have to make 6 requests. I get a lot more data in each of the 6 requests. I think if you compare this one, it's about 500 characters or 500 bytes of information on the GraphQL side compared to 6 requests all around 2,500 characters. So you're many multiples more data when you're using REST. So this is the underfetching problem. In REST, I don't get everything I need in a single request. I have to make multiple requests to get all the data I want. And the ugly side of the underfetching problem is this actually makes the client that you're writing more complex. So I have to make 6 requests across the network. That's the most brittle part of my application. And I have to manage what happens with the data that comes back in each of those requests. So it makes my application more complex versus GraphQL, where I define the query, I get back immediately the data I want, and I can put that to use in my application. Okay, so let's talk about the versioning problem of REST. So does anyone know what happens if I wanted to add an additional field to this film object? Right, what do we have there? We have title, episode, director, producer. I don't know, what if we added Netflix ID to this? Well, what would happen is I'd probably break everyone who's well integrated with this API, because the way REST clients work is they typically deserialize the object that arrives, and this object actually represents a contract. So the front-end client expects exactly this object, and when a new field is added to it, it doesn't get exactly the object it wants, and it tends to break. And this is a long-known problem in REST. So we solve that by adding versions to REST APIs when we need to add fields. Like you often see a version added to the path, or it could be added to a query parameter or to a header. But somehow we manage versions so that I can add that additional field, put that in a version 2, and I don't break version 1 of my REST API for everyone using it. In GraphQL, the contract with the client is defined in my query. So the fact that I have additional fields on the object really means nothing. No one's using the Netflix ID because I hadn't published it before. So if I add that field to my film object, I haven't broken anyone's implementation, and they can immediately take advantage of that new piece of data. So that solves a versioning problem, but it also tends to free up the front end and back end relationship when building an application. So traditionally, people building the front end would make requests of the back end, hey, I need this data. The back end folks would go and build it. They would expose it. The front end people would use it. They'd ask for something else. There was another team that was using that same interface but using it differently. You make a change for one team, it breaks the other team. You had this very brittle relationship. Now, the back-end team can kind of expose as much as they want to, and the front-end team can really take advantage of what's been made available to them. And if they need something new, it can be added by the back-end team, but it's not going to break anyone who's currently using that endpoint. So this tends to help teams move faster. And I think that's probably the #1 thing that people are hoping to get out of using GraphQL, is moving application development faster. Okay, let's talk about one last thing very quickly here. So some of you noticed that as I was typing, I was getting recommendations about things I could use in the API. There's actually a link over here with kind of a full set of documentation as to what this API can do. So in the REST world, I said that this is a really good REST API, this Star Wars API, because it actually includes information that'll point to what you can do with the API. Some REST APIs don't include that, and especially older ones. And you are really dependent on someone having written good documentation so you can figure out how to use the API. In GraphQL, there's really no way to decouple the API from the documentation. The two always travel together. So there's always discoverability, and they refer to it as introspection. You can very easily inspect what's available for you to use. And I'm going to touch on why that is in just a second. Okay, so I'm going to attempt to go back to our slides. All right. Okay, so these are the things we just talked about. Okay, so just very quickly, I thought it'd be worth touching on some terminology. So the reason that documentation always travels with a GraphQL API is that every GraphQL API starts with a definition of the API. The API is defined in a type system in a schema. And that's really what that documentation is exposing. I've written a schema that describes how my API can be used, or how my API is used. That's not only used in development, in use of the API, but it also gets reflected back in the documentation. Every GraphQL API has its schema associated with it. So there are 3 entry points to a GraphQL API. There are queries, so anytime you want to ask for data. There are mutations, so anytime you want to change data, right, create, update, or delete data. And then there are subscriptions, so anytime you're allowed to create subscriptions whereby the backend will publish information back to you over WebSocket as to when data has changed. There's also a term we call a resolver. So mutations, query subscriptions, their business logic is written in something called a resolver. So a resolver is the thing on the back end that decides what to do with your API request. And that's going to be important as we get into talking about AppSync here in a second. And then I just put client and server on here just to make a note that you know, GraphQL is the API layer. So there are client-side concerns and there are server-side concerns that apply to the technology, if that wasn't obvious. Okay, there's one small challenge, I would say, with GraphQL, and that's the fact that the client is writing a query. The person writing the client is writing queries. And we've probably all used applications that were brought to their knees by someone writing a bad SQL query. GraphQL is slightly prone to that as well. I don't think that's slowing many people down, but this is the challenge you have to deal with GraphQL. So you saw that I was able to request resources at different depths. When we asked for Luke, we asked for his films. We could go further and say who are the co-stars in those films. I can actually end up requesting a lot of data in one query because I'm allowed to kind of navigate down that tree. And unlike REST, where I have a single resource endpoint that I might paginate, with GraphQL, where I can request many resources in one query, I can end up asking for an awful lot of data, and you know, that can slow an application down. So this is something that people building applications around GraphQL APIs have to deal with. Okay, any questions about GraphQL, or any of the GraphQL folks want to throw anything in there? Did I miss anything salient? No? Good. Okay, so we'll keep moving. So AWS AppSync, it's relevant because this is Amazon's GraphQL service. How many folks here are aware of AppSync? Kind of maybe about half the group. So the bit in quotes here comes from AWS's marketing material. They describe AppSync as a serverless backend for mobile, web, and enterprise applications. So what Amazon wants you to do is use AppSync as the gateway from your application to do something on their back end. That's what AppSync's really designed for. And this is kind of what the architecture looks like. So on the left-hand side of this, you have client applications that are interacting with a GraphQL API. The document there represents that GraphQL schema that we talked about. So your application will make requests over GraphQL to a GraphQL proxy, and then it's the responsibility of that proxy to figure out and do something on the Amazon, on the AWS backend, typically serverless backend. So, you know, it can do things like execute Lambda functions, write data to a DynamoDB table, write data to Aurora, can do different things. But let's talk about how this works a little bit. So, resolvers, remember I talked about the concept of resolvers in GraphQL. In this architecture, resolvers translate that incoming GraphQL request to do something with what AWS calls a data source. And there's a list of supported data sources with AppSync. And they're DynamoDB, Lambda, Elasticsearch, Aurora, which is AWS's relational database solution, and HTTP. And that translation from incoming GraphQL request to do something on the back end is written in a language called VTL, or Apache Velocity Template Language. So that's meant to be a fairly thin layer to take the GraphQL request that comes in, direct it to the right data source, and maybe apply a small amount of business rules in the process. Okay, so as with most things, this is more easily demonstrated than discussed. Okay, so so in this walkthrough, I want to create an AppSync API, so a GraphQL API using AppSync that front ends a Lambda function. So that's what we're going to walk through here. So I think most folks here have some familiarity with Lambda. So I'm going to start by actually creating my Lambda function. And I've already created this, so you don't have to watch me type. Okay, so this is a very contrived example, by the way. This is not real world. Okay, so I've got a very simple function here. I'm managing a list of to-dos. So our API allows us to create a list of to-dos. We can query the list of to-dos. We can query to get an individual to-do. And I've hard-coded the list of to-dos here in the Lambda function. So there's no database or anything really backing this. The one thing I've done, and I've kind of followed a pattern that Amazon uses in some of their examples, so I don't know if this is good or bad. For each of my GraphQL requests, I could write an individual Lambda function. Instead, what I've done is written one function, and then I've created a case statement whereby I'll switch which code path gets called based on a parameter being included in that translation layer. So instead of creating multiple functions, I'm creating one function, and when I call the function, I'm going to tell it what part of the function I want executed. So just to prove that this is, I don't know, slightly real. Whoops. I wrote some tests for our function. So this is listing to-dos. Okay, so I've got my Lambda function. I'm ready to go create my API. So let's do that. I think we need some hold music or something. Okay, so I can, I'm going to get rid of this. So I could create the API from scratch. That's actually what I've done here in creating this API. The first thing I did after creating the API was to wire up my data source. So this is that Lambda function that we just created. So nothing special here. I've just identified the Lambda function by name. And I actually chose to create a new role that could execute this function. As soon as you create a new role, it becomes an existing role, which is why it looks like an existing role. So once I have my data source connected, I can now go ahead and write the schema for my API. And I have the world's simplest schema here. So I have a to-do that's defined as an object with an ID, a name, and a description. And then I've written a mutation that will add a new to-do. And I've written two queries, one that'll get an individual to-do and one that will list to-dos. So this is a very, very simple example. So there are some bits of the schema here. This may look unfamiliar to some folks. The exclamation mark means a required field. The square brackets indicate arrays. Pretty straightforward stuff once you've played with GraphQL a little bit. So I still have this. So now I have a data source, and I have a description of what I want my API to do. To really bring it to life, I have to create resolvers. I have to say what happens when someone sends me an add to-do request. What happens when someone asks for a list of to-dos, etc. And I can do that here on the right. So this is my add to-do resolver. So I'm choosing my data source. This is the data source we just set up to point to our Lambda function. And then most of this is boilerplate that gets created for me. The only thing I've done is added this additional field to the payload. This defines what code path gets taken in my Lambda function, as I discussed. Other than that, I'm simply passing through the arguments that are provided in the request to the API. And similarly, when I return data, I'm returning what the Lambda function returns. I'm just making sure it's formatted as JSON. So each of my resolvers, this was the add to do resolver, but each of my resolvers really looks very similar. So in the case where we're using Lambda to back our AppSync API, we'll typically pass the business rules down to be interpreted in Lambda. If my data source was a DynamoDB table, there's no opportunity to execute business rules in DynamoDB, so you'd see a little more verbose translation layer here where I might actually execute some business rules to determine how data gets written to that DynamoDB table. But at this point, we have a working, functioning API, and we can start to leverage the graphical interface that's provided with AppSync. This is very similar to that API we saw in the Star Wars GraphQL example. So if I wanted to add a to-do, I could execute this mutation I have up. I could very quickly write a query that would list all of my to-dos, and I'll get an ID and a name. Right, so very straightforward. And you can see again the documentation for what's available through my API is attached directly to the API. And this is all here because of that schema I filled out, right? So I didn't write any documentation. I didn't do anything to make this documentation show up other than define the schema for my API. So the last piece of the puzzle, which I'm not going to show you because we're recording this, is under this settings option. In the settings option, you'd actually see my GraphQL endpoint, so the endpoint that a client will actually hit. Also defined there is my authentication schema, so how am I authenticating to this GraphQL API? I've set up API key. There's some controversy as to whether API keys are appropriate for production or not in AWS. Sometimes they say they are, sometimes they say they're not. You can also integrate your AppSync API with Cognito and also with IAM. Cognito is kind of their preferred approach. There are actually some good links there. Users have to log into the API though if you're going to use Cognito. You can't get an anonymous access. So my authentication scheme is defined under settings, and because I chose API key, the API key itself is also under settings, which is why I don't want to show you what's behind there. Okay, so that's our API. Oops. So that's the stuff we just went through. Okay, so I thought it would be worth spending a minute about how AppSync kind of fits into the broader AWS landscape. I actually didn't know there was such thing as AWS Serverless. I mean, I know that there's serverless, or AWS exposes things that are relevant as a serverless backend, but I was kind of surprised to find out that there's a reference architecture called AWS Serverless. So I went looking for AppSync in that reference architecture, and I couldn't find it. So where does it fit in serverless? Nowhere, I guess, is the answer. But really, it belongs anywhere you see API Gateway. And you can really think of API Gateway and AppSync as being very similar. API Gateway is a relevant entry point for a REST API, gets you into AWS Backend via REST. AppSync gets you into AWS Backend via GraphQL. So I went and pulled out a picture of how they describe API Gateway, and this is what it looks like, right? So you see apps hitting an API, the gateway doing something to pass that through to a backend, whether that's Lambda or other bits of the AWS world. So that picture, although it doesn't look exactly the same, is very similar to what we looked at with GraphQL. They're really following the exact same pattern. So I grabbed a couple of the examples that are up for grabs there on AWS Serverless. So the top example here, you have a web app that's being hosted on S3. A user's interacting with it. They click on something that results in an API request. In this case, they're requesting something from a REST API that's presented from API Gateway, which in turn calls Lambda, which in turn calls DynamoDB. You could just you could pull out API Gateway, drop AppSync in here, and that would all work exactly the same way. You would just be using a GraphQL API as opposed to a REST API. And in fact, in AppSync world, you'd probably attempt to pull out the AWS Lambda layer if all you wanted to do was communicate directly to DynamoDB. AppSync has that notion of using DynamoDB as a data source directly. And then on the bottom, it's really the same example, slightly different flavor. You've got someone using a mobile app, making a request that results in SNS messages being sent out, but doing it through Lambda. So there's no reason, again, that you couldn't put AppSync directly in front of that Lambda function instead of using API Gateway. All right, so let's start to wrap up. So I thought it might be worth talking about some alternatives, and these really are not AppSync alternatives. These are alternatives for hosted GraphQL services. So I think today AWS is still the only one of the big three, and I'll say big four if you include IBM in the cloud picture here, who has a GraphQL service. The others, though, would tell you it's very easy to deploy GraphQL as a server or as an application to a PaaS like Google App Engine, right? You very quickly cobble together something you could deploy to App Engine that would become a GraphQL API. There's also some people that have played with deploying GraphQL APIs as functions. So I know people have done that with Google Firebase. I actually saw someone do it with Lambda, but it's really contrived. You'd have to create an API gateway endpoint that you could hit, pass it through to Lambda, which would then contain the GraphQL API. So it seems something strange about building a REST API to call your GraphQL API. I doubt very much that any of those patterns, deploying it as a function, that is performant at all. So probably maybe useful in dev purposes, but I don't think very relevant to a production discussion. There's a company fairly well known in the GraphQL space, Prisma, who have a cloud solution where I believe you can get a hosted GraphQL environment. And there used to be a product called Launchpad from a company called Apollo, who's probably the most active company in the GraphQL space. They have stopped offering that service, but you can stand up an Apollo service in Code Sandbox or Glitch for dev purposes. And that uses real addressable URLs. So you can create an API that's actually pretty usable for dev purposes in those environments. I actually meant to touch on this when we were on the AWS slides. Anyone familiar with AWS Amplifi? Probably a handful of folks here, a little bit. So AWS Amplify is it's a layer of technology that AWS provides for application developers or front-end developers to make it easy for them to consume back-end resources. So when you create an AppSync API, I should have shown you this, but I can show you now. They suggest to integrate your AppSync API with your front end, whether it's you building an app, an iOS app, an Android app, or a JavaScript app, that you use Amplify to do that. So if you create the API first in AppSync, they'll suggest you use Amplify, but you can also create your front-end application leveraging Amplify and ask Amplify to go and build your back-end API for you. And that's actually what we covered last week at the GraphQL meetup. Oh, so the last thing I just thought I'd share with you guys some resources. If you don't know GraphQL and you're interested in learning more, the place to go is graphql.org. That's the best starting point. There's someone out there has a nice little weekly digest. You keep track of what's going on in GraphQL world. There's a site called How to GraphQL. They write some pretty good end-to-end tutorials. It'll take you from creating a client all the way through to creating a server using different technologies. It's a little bit opinionated for my taste, but it's pretty good if you're just getting started and you kind of want to see the whole process front to back. There's, of course, a meetup for GraphQL. And if you're interested in AppSync in particular or Amplify, there's pretty good samples on the AWS samples GitHub site, but that's just for developers. So that's what I had for you. I'm happy to connect with folks. If you want to connect on Twitter, I'm on LinkedIn. The Lambda AppSync example we went through, I put a blog post up on fullsapps.com to kind of walk through that. So if you want to follow those steps, you can do that there. Thanks. Any questions? Please.
I'm kind of interested in the subscription side. I know you touched on it briefly, but maybe you could just give a quick verbal walkthrough of the life cycle of how that would work. Like, so let's say I have a client that's consumed your service, and I'm showing 3 to-dos on my screen, and then someone else updates the second to-do. What's the sequence of events that gets their change on my screen?
Yeah. Okay. So so you have to use. So actually, Amazon makes available 2 clients that you can use when working with your GraphQL API from the client side. So there's a simplified Amplify client, and then there's a more sophisticated AppSync client, which uses under the covers uses something called the Apollo client. But you can use subscriptions with any one of those. So essentially, you end up creating in one of those clients a WebSocket connection back to the server, and it's up to the actual resolver that's going to actually pass back a notification over that WebSocket connection. So if you place a subscription in your client code, when you do that, it'll open a WebSocket connection to the back end, and it's the responsibility of the back end to then know when that thing you're subscribing to has been updated and return a response back to you. Does that make sense?
Yeah, I think it makes sense.
A little bit?
Is the subscription to the entire query set? Like, regardless of how, let's say I queried 100 records, any one of those changes I'll get notified?
Yeah, so you can build it a couple different ways. So if you were building your own GraphQL backend, your own server, you would actually define the business rules for that. So let's take a decent example, like a chat application. So we have 2 people engaged in a chat. That chat has an ID. You might subscribe to changes just on a chat with that ID, and you will only get back updates for that specific chat. But you could also be looking at like a LinkedIn, right, where you get that subscription of things that have been updated that might be relevant to you, where they'll actually, anytime anything comes in that might be relevant to you, they'll send you a notification to tell you there's more stuff you can go and retrieve. So it's really up to you to define what you want to subscribe to and what gets returned. It's a little more contrived with AWS AppSync because you don't have complete control over writing that resolver. So typically in AppSync, you actually end up subscribing to a mutation. So you say, I want to subscribe to a specific on create, on update, on delete event, and they'll tell you when one of those mutations has been executed, but you can attach an ID to that. So I only want to know when creates have happened on this particular object versus just in general, against everything. Does that make sense a little bit? Anyone else? Please. Yep. Sets of images. Oh, I know what you mean. That's where I went to for this. Right. Yep. Yeah, so it works very similar. It's not going to sound like it works similar. So in REST, you execute an HTTP method at that endpoint. So to create something, you post to it. To update it, you put to it. To delete. So in GraphQL world, there's just a single GraphQL endpoint, and we post to it. And we end up posting. You end up posting what you're looking at over here. So basically, to execute that query, I would post to my GraphQL endpoint that query. And in fact, what you're actually looking at here in the title bar is someone is posting or someone is getting this query. So this bit after the query is actually everything we've highlighted here. So this is a GET request where they've included the body of that query, and it will return that JSON. I see a confused look. No, this would be in code. If you were writing an application like you would with REST, you would do the exact same thing here. So you would have, just like you'd have a REST client, right, where you go and you ask for a resource at a certain endpoint. You do the exact same thing in GraphQL. You're going to use a client. It's going to hit an endpoint. Typically, we do a post, and in the body of that post, we include what operation we want executed. So it's said in REST where we're using verbs and different endpoints to kind of dictate what we get back. In GraphQL, we hit a consistent endpoint. We always do a post, but the description of what we want back is in the body of the message as opposed to in the verbs and the endpoints.
first request is you just want the title for discovery, right? And then maybe the next request that you want is title plus just planets. I don't know. So now there's like a certain communication that you need to
Semantics.
probably.
Yeah, so in,
If that makes sense.
yeah, no, I get where you're going. So in GraphQL, all of that's written into the schema, right? So the reason you use Helios in REST is because you need some way of figuring out what to do from that point, right? So instead in GraphQL, because we've written that schema, we don't have to make a request to figure out what's available. We can start to work with the API, and it'll tell us immediately what's available, what objects are linked. We can navigate through, we can review the documentation. So we don't typically follow patterns like that with GraphQL because, you know, that's Helios is a pattern to make the API discoverable. That's a first-class citizen in GraphQL. It's immediately discoverable, so we don't have to follow those same types of patterns. You can just start working your way through the API and figure out, you know, what's available at, you know, by writing different queries, if that makes sense.
I guess the difference would be that this is only available at design time, whereas in REST, at runtime, you get semantic.
Yeah, that's right.
I see benefits.
I would suggest, though, even in REST, you still have to have the knowledge of what to do with those links that come back, right? So there's still, you're still making design time decisions, I think, even with the Helios pattern. All right. Well, thanks very much.
Maybe, yeah, we can turn off the recording. So let's do the draw. Anybody does not have the ticket? Everybody has a ticket.